code became cheap.
But what about security, safety, and privacy?
Best practices.
Everyone's is an engineer.
The famous garbage in, garbage out problem, right?
Is just chat.
This is totally the future.
Something like that, something crazy. Okay, hello guys, how are you?
Hey, how's it going, Anton?
Yeah, I'm all right, thanks. So that's our third episode, actually. We were joking on the last episode that we only invite Romas, because first two guests were Roma and Roma, but you broke the rule, which is apparently a good thing. So yeah, first and foremost, Idam, really pleasure to have you here. Maybe you could introduce yourself quickly for our viewers and listeners, just say a couple of words about yourself.
Right. Thank you so much for the opportunity. I really appreciate it. So lucky to be here. So hi, everyone. My name is Edin Marco, and I work at Google Cloud. I work as an AI architect. So what I do in my day-to-day is I help customers implement generative AI solutions on the GCP stack. So building their agents, their RAG systems, leveraging Google LLMs and vector stores, compute services, database, etc. And as a hobby, for around 10 years, I've been an instructor on Udemy. Been lucky enough to reach over 200,000 students. And I teach mostly frameworks like LangChain, LangGraph, agentic coding, which is very hot right now. So topics like Cursor, like Claude Code, MCP, and that's pretty much it. Just one quick disclaimer. So before we begin, so everything I say in this episode is my opinions only. So I'm not talking on behalf of the company I'm working for. So so just to make it clear before we start.
Yeah, that's totally all right. Look, we obviously were going to talk about wildlife and pottery, but since you do AI, I guess we'll switch the topic now. But on a serious note, so today we plan to discuss AI-enabled applications in general, and three broader topics we plan to cover is the production deployments of AI-enabled apps, which is, I believe, the topic that is closest to what you do day in and day out, right? We're also going to chat a bit about the front end of AI-enabled apps and what UI, UX patterns that brings and how that changes the way people interact with the solutions and so on and so forth. And we'll obviously do a bit of a sneak peek of how all of that changes us, the engineers, in our day-to-day lives. So without further ado, I think we can start, right? Let's dive into the first topic. And the very first question I'm going to ask is, there is an opinion that the AI-enabled apps is basically just, an app that uses an API, and there is nothing special about that. Do you agree with that? Do you disagree? How much truth in that? And what's the devil's in the details, as always?
So what are you referring to by an AI-enabled app? Are you referring to chatbots in regular SaaS applications or native AI applications?
Let's chat about SaaS bots, for example. Chatbots.
So I partially agree. So this is actually a good question because a lot of companies trying to enforce and to develop AI features on their product. And in a lot of cases, it's not really needed product-wise. So there are many examples where you can simply see it's not natural and nobody is using it. However, on the other hand, you have companies which are shifting and their main product area is going to be AI-powered. So, for example, a good example I like to say is like a company like Torque, which is a cybersecurity company, which does security automation, right? SOAR. And they shifted their approach to being an AI-first company. So this is something they released a product which is called Socrates, which is an autonomous agent, which is going to resolve tickets using their system. So I think this is a good example where actually an AI solution really fits product-wise. And we can really see the value and comparing it to some government website where they simply added a chatbot which doesn't really work and nobody uses.
Right. No, that's fair. But in terms of if we take that from the engineering angle, right? Is there any significant differences to be accounted, especially in production use when we talk about AIs? Let's be honest. For most of people who don't do their own model hosting, they usually just consume some ready-to-use APIs, right? Whether it's Google's APIs or OpenAI APIs or whatever else. And I believe one of the very notorious thing is that at least the performance characteristics of those APIs are slightly different from what we are used to, right? So, for example, people who are working with, I don't know, Facebook Business API are used to have huge throughputs, limits that are essentially non-existent because it's very hard to hit them, right? But when they step into the APIs powering their web apps, it's very different, right? So, from your experience, what is the most significant differences or most important bits to take care of when we deploy an app that is using AI via the API to production, so to many users, to higher load, maybe not Facebook scale, right? Because not everyone is developing Facebook scale, but at least some scale.
Yeah, there are many challenges. So developing an AI application, and I like to think about agents as the best example, is very easy to prototype, but to take it and make it production grade takes a lot of work. And people are saying the phrase production grade a lot of time, but I think not enough people are talking about the depths of it. Because implementing a POC is very, very easy with frameworks like LangChain and Google IDK and AutoGen and Cruya. You can build very impressive demos and POCs, demoing capabilities. But taking it to production, it really like taking a regular web app to production, but it also adds another layer, which is interacting with those AI models, right? And to give you an example of challenges you have to talk with the AI models. So one big challenge is when you scale, it's like you mentioned, is the rate limit. And rate limit is something which can destroy an application if it happens with live users, right? And rate limiting is actually, there are many strategies to handle it. So, for example, the easiest one is to simply throw money on the problem and purchase a reserved capacity from all the model providers that offer that. So you basically pay in advance for the amount of tokens or the amount of throughput you want. And you get that guarantee that you will get it. So in that way, there are no surprises. So I like thinking about this solution like when you have a problem with your database and you said, okay, let's just make this instance bigger, which is a really quick fix. But it's not going to solve the problem, right? Because once you get more scale, then you need to throw more money, and sometime you're going to hit that limit, right, in a cloud database where you don't have a big enough machine, and you really need to think about how are you implementing your solution, right? So this is one strategy to handling those rate limits. Another strategy is to have sort of like a round robin, right? So you can programmatically, and there are open source packages which help you do that. You can round robin through regions. So you can get different regions. When one region fails, there are drawbacks of doing something like that because, so for example, you can pay for egress for if you're going without the region, if you're going to a region where your app is not deployed. So this is, for example, can happen. And second, this can also get rate limited. So a lot of people implement also retry mechanisms and fallbacks to other LLMs, which I think this is the most common and actually works good because if it fails, so you can simply go to another provider. And with models, for example, let's take Anthropic models. Let's say Claude. So you can consume Claude. You can consume it from Anthropic. You can consume it through Google Vertex AI. You can through AWS Bedrock, and there are many places where you can consume it, right? So you can still use the same model, but from different places. So I've also seen this kind of failovers.
Right. Look, you did highlight a bunch of areas, and I'd like to zoom in a few of them one by one because they all seem very, very interesting, right? And the very first area is obviously different providers, right? As you said, there is no shortage of providers, and especially when it comes to, let's say, like smaller providers, smaller in terms of scale or in terms of the model providers, right? What's the landscape looking like right now in end of August 2025, right? Obviously, there are bigger providers like OpenAI and Anthropic, right? There are those almost like white label providers. I'm not sure that's the correct term to say, but Google and Azure, right, who host others models. And there is also a multitude of niche providers. Some of them hosting some specific models like image generation or video generation. Some are just doing, subset of models because they feel like. And of course, there are outliers, I would say, like Cerberus and Grok with a Q. The providers who excel at insane token speeds, obviously at the expense of like some limits in the model, right? So from your experience, what's the distribution like? Do people ever go to those like niche providers at all, or the absolute majority just sticks with, say, Vertex and call it a day?
So it really depends on the application, but from my experience and from what I have witnessed, a lot of people simply stick usually to one cloud provider and consume that from it. I did see also people failing over maybe to other cloud providers, but I didn't see really a case where people went to those niche ones, right?
Right.
It's because unless they were not already a customer of the cloud provider. Because if you're already an existing customer, it's really easy to simply use it from there. And all the data stays there. You don't pay for egress, and you get the same billing. So it has a lot of benefits, right? You have maybe commits that you've signed with the cloud provider, so you need to burn down some of those credits. So there are many advantages to stay with the providers. Maybe I think the smaller ones, but again, I haven't really seen it myself. But maybe indie developers prefer them because it's very easy to set up. You just put credit card, get an API key, and you can get going.
May I ask you, follow up a little bit about the other aspects of production deployments? You mentioned, we started with an easy ones, which are just chatbots in SaaS applications. But okay, deploying it and making it production ready is one thing, but what about security, safety, and privacy? Because we've seen a lot of cases when, people were using chatbot in some SaaS application just as a proxy for OpenAI, or they convinced to sell them Toyota for a few $100 or something like that. It's another huge part of the equation here. So what can you tell about this part?
Yeah, so actually, Dimitri, it's a very good question, and we come from the same security background, and really,
yeah.
and really and really security is a huge issue here. So we just discussed the scale problem, right? So rate limiting and everything, but the security problem is true, and this is a part of making an application production grade, right? You need to handle its security. And while this tech is super cool, it introduces many security issues and security vulnerabilities. And I think we can even discuss this entire hour only that. Because LLMs, they bring themselves, they open out the attack vector because they accept natural language. So the input is infinite, this kind of input. And it really opens the door for things like prompt injection, which I'm sure everybody is talking about, but also in the ecosystem itself. For example, let's take the model context protocol, which is super useful, but thinking about it, it's literally remote code execution, where you simply fork a GitHub repository, you clone it, and you let an LLM run the code there. So it's insane that the adoption is getting, including myself. I use it a lot. It's very convenient, but literally what we're doing is remote code execution on our local machines, right? So if somebody poison and it opens the door for supply chain attacks. If somebody poison not the repo itself, but a package that this repo depends on. So it's really something we should look into. And and I think there are many challenges of taking an application, an AI application, and making it secure-wise, right? You need to sanitize the user input, right? But if you have, for example, agents which have access to tools, so you need to adhere to the least privilege principle. So you need to make sure that those tools, that they have only permission to what they're supposed to do. And what about role-based access control, RBAC? When a user asks for something, we should only look for the records that belongs to the user. So data exploitation, and the list goes on and on and on and on, and things we need to make sure. And for engineers, security is, I think, for most engineers, is maybe the last thing in the list that they're going to do. So they want to ship things fast, and they want to make everybody happy, and they want to get this feature ready. And this is something which is not been looking up to enough, and many challenges there. Yeah.
May I ask you one more thing? Like, from your experience, do you think as an industry we have enough best practices, at least like case studies, good examples, I don't know, patterns, how to make it? I mean, yes, of course, developers don't care about security, and we heard a lot of jokes that S in MCP stands for security and things like that. But do we have good practices for those who are willing to take these steps? Or we are just very young yet?
This is an excellent question, okay? And I really like this question, and the answer is no, and definitely not enough. And I'll even elaborate on that. Is that, let's take open source packages, right? So I'm a big fan of LangChain, really love that package and this framework for building generative applications. But if you take a look at the LangChain documentation and take a look at their security recommendation, you would get pretty decent this description of you need to I think in a gist of everything I talked about, even a bit more. But I think the main point I want to say is that you should not rely on open source to do your security. So people saying, oh, okay, I'm going to go with open source, it's pre-built, RAG chains or whatever, pre-built agents, they assume because it's popular, then it's secure. But this is not the case. And in fact, for example, LangChain, they've gone a huge way, and they recognize that some of their patterns may introduce vulnerabilities. And what they did is that they separated those kind of patterns into different packages, which is called LangChain, I think, experimental, which is indicating that those patterns have vulnerabilities in them, right? So they have gone a long way of understanding. Okay, we can introduce a lot of things and a lot of vulnerabilities, and in order to use something, we need to explicitly say, okay, I recognize it, right? And for example, they have I think it's called a REPL agent or a CSV agent, where it generates Python code, pandas code, and it runs it, right, and executes it. And in order to use it, you have to provide the flag, which is called allow dangerous command equals true, something like that. So I think frameworks, especially LangChain, have been making very good steps in order to accommodate it, but definitely not enough when it comes to building entire applications, right? Because when we right. deploy an application to the cloud, we also have cloud security. And Dimitri and I work together in Orca Security, where we actually build solutions for that, CSPM, and it really introduces a lot of regular challenges that we know, but those challenges are becoming much more dangerous. Because if an AI agent has an AWS role or a Google Cloud Service account with excessive permissions, and to do everything in the cloud environment, then it's acceptable for somebody hijacking it and spinning up VMs to mine crypto. and those cloud bills can grow and grow.
Right. Well, look, at least the good thing, I believe, or silver lining, rather, if you want to call it that, is we as an industry have quite a bit of best practices, and at least some bits like supply chain security, cloud security, and other things, we have something to apply, which is, I guess, is good, right? We're not starting from complete zero, but I do hear you that there is still like a long way to go. And I guess it's natural when the new technology that powerful comes in, you cannot really plan for that, right? So you have to figure on your way almost. Okay.
But I tell you,
okay,
but
look,
I tell you what's more dangerous about it in this era, because today, and it's actually introduces a lot of good. Everyone's is an engineer, because
yeah.
of tools like Cursor, like Cloud Code. And if we're talking about engineers, that security is one of the last things that they want to do. What about a data analyst or a support engineer or somebody from operations? They're not exposed to those things, right? And that's where you can introduce a lot of vulnerabilities for those people, because with frameworks like LangChain and LangGraph, it's actually very easy, to spin up the capabilities, and leveraging those LLM for agentic behavior. But a lot of people who are using it and building it are not core engineers, which is also good, but it really introduces a lot and magnifies the problem, right? So maybe an engineer can go and look into and maybe search in Google for best practices for deploying agents security wise. But I'm not sure that an operations engineer might want to do that. And those in-house applications, those in-house agents, I think those are the ones who are introducing the most risk.
Right. And do you think that platforms help in that in any way? I'll elaborate. So, for example, there are almost like walled gardens like Firebase or Supabase, for example, if you don't really need a fancy backend but need to do something, right? And that usually comes with at least some security practices built in, or at least like data encryption trust things that bits that again quite default but not always present. Do you think it does help those solutions that people create just because it build on a better foundation, or it doesn't really change the picture in your view?
So I think the problem is not the encryption, not the data at rest. I think it's rather the what the application is going to do inherently.
Right.
For example, if it's going to access a database from a user input, then it doesn't really matter if there is encryption at rest or a transit, because somebody can still go and hide with some clever prompt injection, maybe exploitate some information from somebody else, right? And
Right.
the application would do it, like confused deputy attacks.
Right.
So in that cases, it's good that they have it, but I think that the real problem is from the user interaction with those applications.
Oh no! Look, that's obviously like an untapped source of problem, I would say. Look, I'm just thinking that's actually the good thing, my own opinion, because at least your database is not going to be exposed by default with root credentials to the public internet, things like that, which can obviously happen. It happens with engineers, and LLMs only read others' GitHub and take their best practices, right? So whatever they learn, they learn. Okay.
And not a lot of good practices in GitHub. Let's be honest. Lots of code in GitHub is garbage, and this is why we're seeing lots of the code. That those coding agents they produce, they might not always be the best code.
Yeah, the famous garbage in, garbage out problem, right? So unfortunately, that's very true. Okay. Well, look, the security seems to be a very, very deep topic. So let's just seal it for now. I'm sure we'll be getting back to that, especially given your background. Another question that I have is that, almost whatever workflows you build, when they are especially LLM powered, you have to account for errors, right? Unfortunately, even the most beautiful, smart reasoning models nowadays are not error-free, right? And that issue is specifically bad when you have multiple agents working in the chain, right? Because the error rate just compounds. Are there any practices to somehow alleviate that, at least on the back end, when you go production, right? Anything apart from just monitor everything very, very closely and use whatever as simple workflows as possible?
So it's a good question. And first, we can talk about it product wise. And actually, a friend of mine, the Asaf Elovich, which is the head of R&D in Monday.com, also a co-founder of Tavili.com, actually came up with a metric, which is called the CAIR, confidence in AI response, something like that, which basically says that for an AI product to get widely adopted by the user, it needs this metric to be in the end of the scale. And this metric represents the cost of error, right? So how bad if the AI messes up, for example, writing wrong code, and the easiness of the user to fix that mistake, right? So let's take Cursor, for example. It's a widely adopted Cursor Cloud Code. AI makes many coding mistakes, but for a developer who's using it to fix it, it's very easy. You simply prompt it again, right? Simply prompt it again. You get maybe prompt it again and again and again, which is also a problem, but we can discuss it later. And you can have it fixed. So the cost of fixing the problem is low. And the cost of having this problem, right? So if there is an error in the code that it produces, it's not that a big of a deal because it's still in development environment. As long as you're probably going to have a unit test, which is going to test and maybe catch this. So it's not going to be very high. So this is why one explanation why it's being widely adopted, where you have other, for example, products which integrate AI. So this metric there, the cost of fixing something is not might be too high, or the value it's going to give you, it's not going to be high enough. Okay, so with coding agents, the value is very clear, very huge productivity boost, right? Okay, so this was just product wise. Okay, so this was just product wise. Let's talk about engineering, and I think the best way. And this is, I think, what I recommend for every team which is building an AI application, is to start creating datasets, to start recording those user inputs and the outputs and everything in the way. Okay, just saving it. I know it's going to cost storage, but once we're starting to do it, we can start go and curate a dataset. Okay, and this data set, it can be also used for us to be labeling it later for good responses, bad responses through the entire trajectory of the application. If we had multiple LLM calls, we had tool calling, so we can check, if everything went through or something was problematic. And those are going to help us create evaluators. Okay, and they're going to help us create now these evaluators to monitor our application. For example, if a user is going to input to the application an input, I want to order a ticket, okay? And at the end, after the agent is going to do its work, after it's going to make the tool calls, it's going to return the ticket, and user saying thank you, for example, this can be labeled as a good example. And those data sets and this evaluation, it can happen, the evaluation can happen online. So on the deployed application. So on the deployed application, you can also track it, and it also can be offline when you run your tests, if you change a prompt, for example.
Right. Okay. Look, that does make sense. Any advice for cases when you build this AI workflow or workflows that has to run without the user intervention, as in maybe some background process, maybe some batch process, and basically, it's somewhat easier when you have the supervision by the user in some shape or form, right? But what do we do when there is no supervision, or at least it's very hard to impose one?
So I think, I think this is where LangGraph actually was the first one to introduce it. So the key word here is agentic workflow. And the key point here is that we, as the developers of the system, we can create the workflow, what the app is doing. We can have a node here. So LangGraph, just to give for those of you who are not familiar with LangGraph is to build that. It's sort of like Airflow, but it's going to allow us with cycles. Okay, and we can have LLMs deciding where to go in those graphs. Okay, so in LangGraph, we as developers, we can create the application graph where each node is going to perform some other operation, and we can have the LLM go and decide whether we need to go on this route or in that route. And
Right.
when we do that, we maybe might not have an autonomous agent which is doing everything. We take this freedom concept, from the LLM, from it can do anything, it can run anything, can invoke any tool, and we take this freedom idea and we take it simply one level down. And by doing that, we can have an LLM which is deciding where to go in this workflow and still get agentic behavior, and still get some very advanced tech, but we actually make our application much more robust because we define the flow itself. Okay, the LLM can move in between, but we coded it, so we know what it can do. So it can go off rails, for example, and we can programmatically code, guardrails. If you've been in this node 3 times, simply stop and go and go back and try something else.
Like report an error, maybe, if you didn't manage to. Yeah, that makes sense.
Yeah, exactly like that. Yeah.
Okay. And but the very reasonable question would be, okay, but how we find the balance, right? Because if you go super deep into your workflow and you describe almost any branching that there is, you almost diminish the use of LLM, right? Or at least reduces to the very minimum, right? What about the free will of LLM? These magical things when a swarm of agents decides how to solve the task in an unorthodox way, if you please. What's where do we stop? How do we do that?
Yeah, so it's actually quite interesting, right? So I mean, to give the LLM, to do everything, this AGI, we're not there yet. We're very close to it, by the way, with the concept of deep agents, which introduced, coding agents like Cloud Code are very good examples of that, because Cloud Code doesn't have any predefined workflow that it's doing, and it still has amazing capabilities, right? So and Harrison Chase, the guy who created LangChain, actually kind of reverse engineered how it's built, and really came up with this concept of deep agents, which can perform deep tasks and solve really complex things. And it came up with a couple of characteristics which helped us achieve this, and get better performance, like in those coding agents, right? So let me tell you, for example, what's mentioned there. So in Cloud Code, for example, you have a to-do list. So Cloud Code has a tool which is a to-do list, which it's not going to change any to-do list which is existing. It's simply going to write it and write it. And by having that simple tool, which is going to run alongside with the context of the conversation of what's happening so far, it's actually going to give you very good results of doing with the top tier models of achieving a task. So this is, for example, this is a one characteristics deep agent introduced, and the other one is a planning tool. So besides having a to-do list, it's going to have a planning tool, which is going to plan, the next steps, and then it's going to create this to-do list, right? And having both of them, actually, it's going to give you this kind of behavior where it's going to be very deep and complex and can solve problems, And to Cloud Code, you can give it examples, for example, to implement very complex features end to end, and it will install the packages and it will do anything for you.
Okay, guys, we've been discussing this production parts and backend stuff for a while, and I have also experience in frontends, which makes me curious about how AI actually changed the way applications behave and look like. Because I'm I'm very upset that majority of the things we are seeing right now is just another button in form of, I don't know, crystal, star, whatever, which will open you a side panel with a chat. So, Ethan, have you seen any good examples of how AI changes UI, how AI changes products in terms of how they feel and work and look, rather than just adding another button?
So I think we all seen it, in for example, in ChatGPT, they came or any other, a chat application, from the big vendors. When you started to introduce tools, for example, search or even deep research, you actually see in the user interface, you're seeing what the agent is doing. It's searching online, then it shows you a preview of the results, then it says, okay, now I'm summarizing everything, now I'm creating sub-questions. So through the entire way and through the entire life cycle of the application, then you simply go and you see what's happening. So I think this is, for example, very good example of good generative UI because it creates trust with the user, and users shouldn't trust AI systems inherently. We should always doubt them. And once you see all the steps that the agent is doing, you can see, okay, it's doing what it's supposed to do. It's not going off rails. It's really what I would do if I was to search in it. And this trust, it's eventually going to lead that the user is going to trust the answer and have a good experience, And I think this is something that we worked toward, right? So the chat at the beginning didn't have, for example, searching capabilities, and it was just text in, text out. But now with all those features, we're starting to see really nice patterns. How about you? Have you seen any interfaces that you like?
I wish I had, because all I'm seeing is just chat, and I want something more, honestly. I would like to see some changes of a magnitude, like we've got touch screens. Touch screens redefine UIs quite significantly. And AI, everyone talks that it's much more powerful and much more richer technology. So I would like to see new patterns, like completely different from what we have. And so far, what I'm seeing is advanced chats, which makes me a little bit upset. So I wish I had, but I haven't.
So there are different user interface. Have you heard about ambient agents? So ambient agents is like you can imagine it like having an email box where you have different entries where every entry is going to be, you're going to get emails, you're going to get notifications for your agent. I've did this, I'm doing this, I just finished this task, I'm now researching on this. And you have a place where you can simply go in approve, not approve, and like you have assistants which are, telling you how they're progressing, those agents are going to do it as well. So this idea of having like this inbox where you as the human control and the agents are going to pop up those notifications and the human in the loop and approvals, and maybe you need to give another input, or maybe you want to stop the entire flow. So this is also another interesting idea of the user interface of those kinds of applications. And I think this is something that we haven't cracked up yet. And I think this is something we haven't cracked up. But I think that we have also in Cloud Code, for example, in Cloud Code is CLI tool, right? And you see many open source of people creating user interfaces on top of that. So you can have multiple instances of Cloud Code and lots of cool things. Like I think Claudia is a very, very famous one. So we're on the way, I think.
So your opinion, we're just not there yet.
Yes.
Yeah?
Yes.
Funny thing. Once we were preparing for that, Anton mentioned this old famous scene about streaming text, like OpenAI, when they introduced ChatGPT, the model was slow. So instead of making users wait, they started streaming text, and it's like text appearing on screen, character by character, line by line. Now models are faster, and it's still like default way of doing chat interactions for many scenes, which is like legacy scene which stayed with us for a while. And I have a fear, honestly, that we're gonna have more of this kind of scenes. And my opinion is the longer we sit on what we have, the smaller the chances that we're gonna have some kind of disruptive patterns. But this is just my personal opinion.
Sorry, can you please elaborate on that? I'm not
I
sure.
mean, like we're used to chats, and we will live with chats for 5 more years. I really doubt we're gonna be having something else rather than chats. So the faster we have something, the more chances we're gonna get something.
Yeah.
And the longer we sit on what we have, the smaller the chances are.
To be honest, I don't like chat as well. No, it's horrible. It's not fun.
Quite
interface.
slow, yeah, it's not fun. Yeah, that's fair. Speaking of which, have you seen any examples of, you already mentioned this thing that's called generative interface, right? Have you seen some product or somebody who's taken that one step forward? Because I'll explain. There is like a dream I have is that maybe one day my mail application is going to lose all it has right now, and every email is going to have almost like, a unique representation. Like if there is something you just need to read, it's going to be like a sticker that you read and close. If there is something that needs to reply, there's going to be like quick reply buttons. If there is something that needs to connect to other people or check the calendar, it's going to be showing side by side, all those bits, right? And it looks like we're almost there with all the LLM capabilities. I don't think it's a stretch to say that for certain bits like that, the LLM can decide or can even dynamically assemble, obviously like some predefined controls or whatever, right? But now the question is, do we have any implementations of that? An app that, almost doesn't have the interface because the interface is very different for every situation, every user, something like that, something crazy. Or it's not crazy already, I don't know, maybe everyone's using that. I'm just like, the old guy.
So I like this example. I think this is totally the future. Okay, let's start with that. I haven't seen anything like that. I can talk about I think, about the user interface of a Cursor, which I really like. I mean, they did some excellent job there. But I want to talk about the stack and the tech that we have today, which can actually generate those kinds of things.
Yeah.
So, and by the way, Cloud Code introduced a couple of, I think a week ago or 2 weeks ago, they introduced the concept of output styles. And Have you heard about it?
Yeah, briefly, but I think for the audience, it would be good to elaborate. Yeah.
Okay, so with output styles, you can think about it is that you ask a question, Cloud Code, and you get an answer. Usually it's going to be a diff, or it's going to be some answer to what you asked, if it's a question about the code, for example. But let's say you want something tailored made to your needs, okay? You can actually go and define what is called an output style. And with an output style, I can say, I want my outputs to be in YAML format. And once you're going to do that, and you're going to create this output style, which is very easy, it's simply a prompt. Basically, it's simply a markdown document, which is going to describe how you want your output to be. Every response you're going to get from Cloud Code is going to be according to this output style. So if we're talking, for example, about YAML, then you would get, this YAML structure where it has this a child and parent relationships, right? So once LLM creates this, it's really a different way to communicate with the human, because YAML files are very easy to read by humans, and you can get very concise information, and you can get a lot of advantages from doing that. So you can go with YAML, you can create Markdown, you can, I saw somebody go create HTML files which open up in a browser in a blog style, right? Theoretically, you can actually build a Next.js application and tell it, hey, I want you to each answer to create a page in that Next.js application. So this tech to transform this mailing application to generate on the fly, this custom UI is actually, we have this kind of tech. And
that's what I'm saying. It's almost there, right?
Yeah, it's totally there, and I think we're very close to having that. think we're very close to having that. And by the way, outputs that in a Cloud Code, the actual implementation, which is a bit counterintuitive, it's not that it's taking the result and piping it to to Claude with your prompt. It's actually going to replace a part of the system prompt. So this is something interesting.
That's fair to influence what the LM actually outputs. On the topic of that, by the way, I see it's becoming almost a norm, and I guess engineers are already used to that. But again, because you use LM, is you already mentioned you can provide custom prompt to do something, well, in this case, output styles, right? But I mean, in general, do you think it's going to become a new norm for the app instead of, again, thinking future, right? But instead of having the settings screen in the app, there is a text box where you come and say, yeah, I prefer my app to be in Spanish and always use dark mode and please no sounds, rather than having all this like switches and dials and whatever, right? Do you think it's going to happen, or do you see it's happening already?
Totally. I haven't seen it happening, but I think we're towards there, because I think it's going to be with those AI-powered applications, the ones that they have really AI at its core, and not just, an e-commerce website which are adding a chatbot. This is not going to be the case, but those agentic applications where AI is at core and the LLM is the center there, which is making a lot of decisions, which is going to execute a lot of things. So it's inevitable for human language to define the configuration of this, for sure.
Right. Yeah. Look, I think that again, it's definitely doable in many instances. We just need to fight this blank canvas fear, if you please. That many people just get lost when they see this text box. It's like, yeah, what can I type in there? Like, what's my next step, right? But yeah, I'm totally on board. I very much like this approach, and especially it's very nice for engineers as well, right? You don't have to code all these screens. It's just like the AI does it for you. You basically sign off. Speaking of challenges, let's then switch to our last section, right? And how we can say that, with great challenges also comes great tooling, right? And I believe it's fair to say, we already mentioned that multiple times, is that our lives as engineers has already changed. I think now we can say that. We could have said that actually like a year ago, but now it's unfair to say otherwise. And I'm sure even more things are coming, right? So let's start with a bird's eye view. Eden, excuse me for that preset almost question, but if you were to name 3 things that changed the most dramatically during last year because of generative AI in engineering, I mean, day-to-day engineering or whatever engineers do or how they organize their work, just from that angle, what would you name? What would you bring?
Yeah, so I think that the first thing that's on top of my head, I think the first thing on top of my mind is that code became cheap. Just like storage was expensive, now it's cheap. Today, code is cheap. So to produce code, not saying high quality code, but to produce code doesn't cost as much as it used to. If we wanted to create a startup and we had to raise capital, it's for engineers to go and to do that. So now we can take that and we can use much less resources in order to get code. So I think code is becoming something which is much more expandable. We can produce tons of code with AI, with tools like Cursor, and we might not use all of this code, and we might throw 90% of this code to the garbage because it's that cheap, and we can only take that 10%. So I think this is something which dramatically changed. And it's a huge paradigm shift, and I think also VCs, really thinking about, okay, now it's really something which introduces lots of changes to many industries. So this is, I think, first thing. So it's very easy to create code. And I think because it's easy, it also bridges the gap of technologies. So I think in the past, we had front-end engineers, back-end engineers, low-level engineers, FPGA and DevOps. And I think this data scientists, machine learning engineers, whatever, I think this gap between all those engineer types is starting to close because backend engineers like I was are becoming full stack developers suddenly because of those kinds of AI assisting coding tools. And they can build very impressive UIs. Like Dimitri said, yeah, maybe it's not going to be perfect and they might get 80%, but sometimes 80% is enough. And for somebody who is a Python developer, to switch and to write now a Go application is not that, it's not hard as it used to be. Okay, he doesn't need even to open the documentation of Go. Can use AI assisted coding to do that. So I think this gap is being bridged. And my last sentence in here is that I want to say that in 2 years from now, or 3 years from now, we're not going to have Python engineers or Go engineers or front end. We're only going to have engineers. So they have the full skill set with AI. So this is
Maybe
the
we
first
will
thing.
not have engineers at all. You're not that pessimistic?
Somebody needs to write those bugs, you know.
That the AI is going to fix, yeah. It's actually fascinating because, if we come back to the paper from what it started, attention is all you need, right? It was studying the transformers, and the application was actually translations, right? It was natural language translations, which is a bit different, but in some sense, you can say that what AI coding do is they translate your human language and human input, human instructions into the code, right? So in some sense, that's also like, it does a lot of things on the way as well. I'm not saying it's just doing that, right? Otherwise, it would be just a very, very, very smart typing machine. But it's actually fascinating, as I said, is because in some sense, the purpose for which LLMs were built or how they were discovered, depends on how you approach that, is exactly what serves the best, which is, again, logical, right?
But what is coding? You know, coding is also translating your thoughts into machine.
Yeah. That's what I'm saying. It's in some sense, it's just a language-to-language translation, right? Which is fabulous. Okay, look, you did mention a few very strong statements about engineers becoming just engineers, right, and not specializing in whatever. And we'll obviously see how that ages, right? So we'll screenshot that tweet, as they say. But again, that speaking of today, do you think there is any slice of maybe like types of jobs or groups of jobs that are being eliminated already, right? So even before we erase specialization, maybe you notice that, I don't know, people are not hiring junior engineers anymore because Claude Code is good enough, or something like that. Any trends that you spot, and
So it's actually quite interesting. I think I saw a quote of, I think it was AWS CEO or somebody from AWS. You saw that, Dimitri? What was the quote? What was the quote?
You mean the one about the idea of not hiring junior engineers is the most stupid thing he heard for a while?
Yes.
Yeah, I've seen this one.
Yes.
Unfortunately, everyone does it, and we were raising this topic for a while, and we are asking okay, if we don't have junior guys today, how the hell we're gonna get seniors in 5 years? But it's just business.
And Anton, are you hiring junior engineers?
Not at the moment, no, but not because we don't like junior engineers. It's just because our team is very, very small, and we just don't have the resources to, grow and watch after properly. But we're not opposed to, by the way. If we were bigger, we probably would still hire some. I mean, today, right? Ask me tomorrow. Maybe things change. But yeah, they don't have the strict no policy of hiring or whatever talent. Yeah. Okay. Look, maybe it's not about junior engineers. Maybe it's about the type of work that people are doing. Right. Anything in there? Anything?
I cannot. Yeah. So by the way, junior engineers, I do see trend cross-wide. Junior, like fresh graduates, having very hard time to get job. Very hard time, and I think it's really a problem. A lot of people are finishing up computer science degrees, which is a very hard degree, and having a hard time to find a job. And I think the word here is really changing. And because what is a junior engineer is when you onboard a junior engineer, you give them well-defined, well-scoped tasks.
Yep.
And if you can define those well-defined scopes, you might have give it to an LLM, which can do it in 20 minutes and already knows your entire stack and your entire CI/CD, and can run the unit tests and the linting and to do everything like that. So I really think that. I don't know how it's going to look like, but this is a problem in my opinion. Not really sure how this future is going to be on that.
No, look, that's fair. Sometimes it's really hard for a business, especially, to justify a hire when there is this sweet alternative, right? And I believe what also makes it somewhat easier for people to dismiss is that they say, okay, well, we're not gonna grow the junior into the middle, into the senior in-house. We're just gonna hire in-house senior whatever later when we need it, right? And obviously, as Dima stated, no one really thinks about what happens when there is just no junior engineers and no one is breathing them right into that. Okay, that is fair. Do you think there are any jobs that are on the brink of eliminations and they're still around today? Yeah, okay. Well, a couple examples that you think are most.
Yeah, lots of jobs. First tier customer support, and I think it's pretty obvious that it's going to go. Even telephonic representatives. With even though that, to be honest, the voice technology is pretty hard to implement, especially in production grade. All those voice models, very hard to implement and to monitor and to handle them. But we're very close to creating a solution that is going to take care of all of that. So the first tier support, this is, for example, I think that also testing and QAing, I think this is something which is also going to be automated, with tools like Playwright, and LLMs are multimodal now. So it's very, it's just a matter of time until we get massive automations in that. And also, I think engineering in general, to be honest, I think that we're going to have in the near future much less engineers. Software developers. We can maybe circle back on that in a couple of years from now. Is that because I like to think about it just like, when the tractor was introduced to plow the field. So you don't need as much as farmers. You would need maybe one farmer to drive the tractor. But eventually all the rest you don't really need. And the amount of land you can farm is finite. Okay, and this is what I'm going for, is that maybe we're going to have new companies, new products, new features, everything. It doesn't mean that everything in the world is going to be implemented and we're going to need much more engineers, in my opinion. So thinking also engineering. And just like, artists, when the generative AI boom came, so people were saying, hey, we can never replace artists and, these kind of things. And now you can simply generate, by the way, those pictures I have right here on the wall, they're AI generated, this parrot, so it's just to show you that the ones we thought that are going to be replaced last were actually the first to be replaced. Same thing from engineers. And by the way, I think it was like a year ago, I said that backend engineers will never be replaced. You really need to know how to talk to the databases and, deadlocks and, queues and scaling and all of that. And this is totally not the case. And we're seeing right now that also those coding agents are really doing a lot of this work. In this architecture, they can actually do it even better than ourselves.
Yeah, that's fair. I guess one bit, I unfortunately don't remember who said that and when, but I heard recently that probably the next step that we all wait for is to have a $1 billion company run by a $1 billion technology company run by a single person. with the help of AI, obviously. But I think it's going to be like a good milestone, and
Wow,
might
yeah.
happen. Maybe it's happening already.
And by the way, all of those the many unicorns like Cursor, like Laravel, they have very small teams.
Oh yeah, definitely. Yeah.
Their team is super small. Yeah.
Yeah, I guess they eat their own dog food, right? And use the tools they created.
Inan, you are the person who also involved into education. You create courses, you train people. Could you please tell us a little bit how education itself changed? Because like from engineering perspective, I'm not sure that it changed for good, because like how we all learned engineering. You suffer, you debug it for a while, then you learn from your mistakes, because you gain this knowledge not very cheap. Or sometimes you suffer for a while, then you go and reach out for solutions like on Stack Overflow or somewhere else. You try one, you try another one, you try the third one, so you can build some patterns, some neural paths in your brain, and you learn from that. Now there is no need for this suffering. You can take it out. You can just ask LLM and you're gonna get an answer immediately. You don't even need to read for a stack trace in many cases. You just copy it, paste it, and it's gonna fix for you. So what's your opinion about education, how it changed, and does it change for good or not so much?
Yeah. So by the way, the code you don't even need to today to copy and paste it. You can use like MCP servers which can stream console logs right to your terminal and to feed that to the agent. So education. So I can tell you about interesting trends I'm seeing. So I teach technical topics to develop LLM applications, and at the beginning, the target audience was developers, software engineers who want to, become AI engineers and to build those AI solutions. And I see a trend where most of my students now, not only that they're not software engineers, a lot of them, data scientists and data analysts, which maybe know a bit of SQL, a bit of Python. But I'm actually seeing a lot of people who had no coding experience at all. Lawyers. Okay? I had a bunch of lawyers and a bunch of doctors, medical doctors, take my course and start building things. So I think the first things I'm saying, I'm seeing that really we talked about the barrier that I think it's being it's being breached and it no longer exists. So this is one thing that is interesting in education. So basically, people who are not maybe the natural candidates for doing technical things are doing technical things. Okay, so this is the first thing in education. Second, education is changing dramatically. So just like you said it yourself that you had to suffer and then learn and maybe look at Google and look for Stack Overflow for answers. But right now, you can do it with an LLM and get the answer. But the next evolution of LLMs is this is things we're seeing now in the last couple of days and weeks. Is that, for example, Cloud Code introduces a sub agent which is helping you to learn things. Okay. Also, I think Google I think Google Gemini, the user-facing application. I think it also introduces like a learning paradigm. So you're starting to learn new things with the LLM, which brings a lot of problems because LLMs can hallucinate and they might not also always have the correct information, and sometimes they can be misleading. And you were studying from a teacher all the time, and now you're studying from an LLM, but who knows if that LLM knows what it's talking about? Because it's really it's really digested the internet. So there are a lot of things in the internet, and if you study history, for example, then maybe what you're going to be reading is a bunch of posts on Reddit, which are going to be, handling the weights, and and you're going to be studying wrong facts, which are simply not true. So, yeah.
Yeah, grounding the answers is one big problem, and for that matter, actually very much like perplexity, because you know that when you ask, you get the response and quotes immediately to the source proving that. But in all honesty, ChatGPT does that if you ask it as well quite well, and sometimes by default. Okay, well that's intense, but let's say we are now, as in now 2025, and we have probably the best person in terms of continuing the evolution is a software engineer with a lot of experience. So already knows his craft and wants to continue being an engineer, and now is faced with basically the reality of LLMs being all around and everything, right? And the overarching question is, of course, is okay, how do I take advantage of all of that? What like let's say I'm an engineer who never used anything, like I don't know, they haven't used Cloud Code, never used Copilot, just familiar with the concepts, of course, because I think you cannot be an engineer and not be familiar with the concepts nowadays, right? So what would you recommend as the absolute musts for such a person to start using, and the maybe absolute musts after that? Actually, yeah, let's cut the chase a bit. Let's say the person learns LLMs and Cloud Code and Copilot, right? What would you recommend for that person to utilize to stay relevant, basically, and to not have a hard time looking for a job in 6 months or whatever?
Yeah, I like it, and I think first of all, there's some concepts like very important to know. For example, MCPs. When to configure MCPs with Cloud and Cursor, and your other agents, because it's very useful. So I think this is an important thing to know. I think software engineering now is about being a good welder. So to touch many technologies and to simply choose the correct ones, and tell the AI to code and to do things, but you need to know what to do and to connect to Postgres, and maybe why to choose Postgres and not MongoDB or Firestore or Elasticsearch. So I think being like an architect, to have the architecture skill, to know the trade-offs, which by the way is kind of like also a caveat, because you can become an architect after you've learned a lot of things and you coded a lot of things, and you've experienced on your own flesh what works, what doesn't work, what scales, what doesn't scale. And so it's really not that easy, easier said than done. This is the first thing. I think that those LLM agents, those coding agents, they introduce a new paradigm shift. A new paradigm shift of developing, because right now I said earlier that code is cheap, but we can also scale ourselves as developers, and there are many workflows where we can create and scale us. And this is something I personally did a couple of days ago. I spun up like 15 agents which implemented a user interface component in 15 different flavors, and I just chose the one that I liked, right? So the notion of scaling yourself is something which is important, and the skill to be able to do that is also, in my opinion, going to be very useful in the future. And I think taste, right? So having a good taste, so to see what's good, what output is good, what output is bad, is very important working with those kinds of systems. And the number one skill, I think, is that knowing when not to use those systems. Okay, and I can,
as always,
and if you're working with things like Cursor, for example, and you're addicted to it, I highly recommend you trying to switch off for a day or two the tab completion feature, and just go back to what you used to do, and write code yourself, and I think you learn a lot of things. But I think you can learn a lot by doing it. This is when not to use AI is important, because going to this dummy mode where you simply prompt and prompt and prompt and fix this 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 because and no, this is not working, fix this and fix that, pasting the logs, it simply doesn't it doesn't scale, right? And you can find yourself wasting tons of time, where if you simply understood what was the problem, which AI is very good at doing, to analyze the code and tell you, you could have gone and solved that problem much easier.
Yeah, that actually resonates a lot with me. And one of the things I believe is just indispensable is that, as you said, you basically eliminate the barriers between the people and the technologies. And especially if you are quite an experienced engineer, I think there is almost unlimited amount of possibilities you open for just trying things, right? Because circling back to your example of being a good architect or whatever, you kind of have to know what works, when it works, as you said, when to choose Mongo versus Postgre versus Firestore versus whatever, right? And before that, let's be honest, it was quite a labor-intensive thing. You either had to work with those technologies on the production projects, and to be well-versed in all of them, you have to spend a good amount of time in every of them, right? Or you have to do a lot of experimentation. And in my experience, engineers are very, very reluctant to do experimentation because you have to set this up and you have to deploy it and you have to not forget to dismount that after, because it's going to burn your cloud bill and stuff like that. And now with LLMs, it's actually becoming much, much easier, because you can really say look, here's my 10 agents, each gets a database of choice or whatever. Again, building on your example, right? Go build me whatever app I'm building, just a prototype, and just see what comes out, right? It might be not the best implementation in there, but you'll at least see something, and you'll have something to play with, right? Which otherwise would have taken you days and days and days. And because that's a very disposable piece of code, it's not something that you're going to reuse, let's be honest, right? It's a toy that you're going to erase at the end of the day. Creating that in an automated way, quickly and in a cheap way, I think it's great. And, that really opens a lot of possibilities. But as you correctly stated, the underlying bit is that you have to have some experience and understanding of what's going on. Otherwise, you probably could be poking random bits. But you're going to be poking them very, very quickly, though, so.
I like that, but and I like it because, what was learning? Let's talk about learning a new technology, right? Yep. So let's say I want to learn Elasticsearch. So I need to go, and I used to go to their documentation and check out their SDK and see how I can configure the DB, and then I need to how to configure my indices, and then how to use their SDKs in Python, and a lot of this work right now can be automated with an LLM. I can simply say, okay, yeah, I have this index. Please, I want you to work with it, and I want to pull this kind of data, and it writes, the query. And okay, this query is not working good. How can you optimize it? How can you make it better? So those kinds of iterations are really, really faster now.
Right. Yeah, that makes sense.
You remember when we were all learning software engineering, there was a mantra that you need to be on the highest possible abstraction level you can be at. And now with LLMs, it's just shifted beyond the code. So your abstraction layer is not code anymore. And sometimes it's not even design anymore. It's overall thinking about product, maybe, or maybe overall thinking of business. So does it mean that being a good engineer in 2025 and forward is not being engineer in a classical understanding of it?
Yeah, good question. Yeah, I think, engineers have quite a character, so lots of debating and I'm right, you're right, lots of ego there, and I think this is something which is going to disappear, and, and I agree, engineers are going to be more product people. Product people are becoming more engineers. And by the way, Dimitri, this is good, interesting point. What do you think is the next abstraction that we're going to have? So now we have language. What's the next one?
Yeah, hopefully brain to computer interface at least, because I'm not agreeing to anything less than that. It's just going to be boring. I have one more philosophical question almost. And again, it's quite broad, so I'll try to contain it in a reasonable sense. So where do you think the software development will go in terms of so-called resilience, right? I mean, at the moment, I think if you look at software products and especially platforms and SDKs and libraries that we use, I believe that's fair to say there are two very, very different approaches of building the systems in general, right? The first approach is that basically that's what Kafka or ClickHouse uses a lot, is that the software should work no matter what. Even if something is slightly wrong, the configuration error or whatever, let's try fixing that. Let's try recovering. Basically, it tries to be as resilient as possible. And that's obviously very, very nice for humans because we all make mistakes. And it's nice when the software is forgiven, when it's not giving you a hard time because you forgot to remove this comma in a JSON, that they always have, and the parser is too strict or something like that. And obviously, the another spectrum is... actually, most of the software, and Elasticsearch is going to be a good example, is that you have to configure everything, even things that are like everyone configures in the same way. It has to be very explicit. Any error is a hard error, or like most of the errors is hard errors, right? And that's how we roll, right? And that is also easier for people, just for different type of field, for people who build the software, right? Because they don't have to think about all these edge cases or what I do if the person suddenly types the command does not exist, and so on and so forth. And to me, it's not obvious what's going to happen in the LLM world, right? Because on one hand, it seems like if the software is more resilient, it's going to be easier for LLMs to talk to it, because again, LLMs also make mistakes, and that means that software starts winning, right? On the other hand, it's not a problem for LLM to learn the intrinsic and specifics of whatever, configure Elasticsearch and just repeat it, because, whatever is like another page of text, fine, So what do you think is going to happen? Who's going to win in this world?
It's an interesting question. Actually, it reminds me, I think I just saw a YouTube video comparing Japanese cars to German cars.
Okay.
And Japanese cars are built for them to be misused, and
Right.
for people not to maintain them, and they're very resilient. So at least that's what the video said. While if you buy a German car, then you need to treat it well, and you need to maintain it, for it to work as it's intended, and then it can last you, forever.
Right.
So I think that. My intuition, and again, this is just my intuition, tells me that
Obviously.
we will be going to a place where people can, the people who develop the systems, they can make it less strict, and to indeed give room for mistakes, because LLMs are very good of taking this output and correcting themselves.
Right.
But this is just my intuition, really.
I heard a very interesting concept which is called like self-healing systems, which is basically like, maybe it's wishful thinking at the current moment, but like, remember the cases when we were all in charge of making things in production running smooth, and you're getting some notifications that, I don't know, your database instance is out of memory. How you immediately fix it? You add memory. Is LLM capable of doing it right now? Sure. It could be a self-healing system which will add some memory and, I don't know, notify humans that, okay, this happened. So it could self-mitigate it. Or if it's going to be an edge case when, I don't know, person typed in text into number field, and your design software was not accounted for it. There were no validation. LLM could simply add it right now. So maybe it's going to be neither non-resilient and non-resilient, but some kind of self-healing systems. But I'm too afraid to think about it deeper.
Right. Okay, look, I think it's fair to say that we covered quite a bit of topics today, and very varying topics. And it's been a true pleasure talking to you, Eden. Thank you very much for attending. And yeah, that signifies the end of the show, I guess. Thank you, guys.
Amazing. Thank you so much for the opportunity. Thank you.
Thank you very much. See ya.
Thank you. Bye-bye.